Today we are here to study about electricity. It is a chapter of class 10. So, what is electricity? In modern time, we can see there are various equipment in our house through that is run on electric current. So, what is electric current? We can discuss here about electric current. That is basic definition. That is the flow of charge, or we say electron. The flow of electron or charge called electric current. We can see here the flow of charge. What it means? If any metal have the free electrons, like if we say about aluminum, its outer shell have three free electrons, and these free electrons flow and through which it conduct electricity. Now we have seen here term charge. Then first we discuss about what is charge. We can say charge is fundamental property of matter. Just like mass, as every element or compound or every particle present in the universe have some mass, same as every particle present in this universe have also some charge. So charge is fundamental property of matter. It is of two types. First one is positive charge, and second one is negative charge. Positive and negative charge, which is of two types. Now, what is the property of charge? As it's a fundamental property of matter, then that's why it's also have some property like like charge or same charge repel each other, or we can say move away from each other. Its first property, that same charge like positive and positive never attract each other, negative and negative never attract each other. And another property is, that is, you can say second property, unlike or different charge attract each other. Like positive always move towards negative, and negative also always move towards positive. So this is our property of charges and electric current. Now we have to discuss which kind of material conduct electric current or which kind of material does not conduct electric current. Okay, so there are two kinds of material. First name is conductor, conductor, those material through which electric current passes, or we can say the material in which electric current easily passes called conductor. As its name, we can also see here there is a word conduct in conductor. That means the material which conduct electricity called conductor, like metals, like all metals except diamond. Conductors, all metals I say, that means copper, silver, gold, etc. All these metals have some free electron through which electricity can passes. By the help of free electrons, electricity can easily pass in conductor. And second one is insulator. Those materials which cannot conduct electricity called insulator, or we can say the material through which electricity cannot pass easily called insulator, like wood. Wood never conduct electricity. Plastics, rubber, etc. These are the materials which never conduct electricity. We can also say in our house, that is in wire. That wire we can see in our house in our daily use. The metal part is covered with non-metal, with insulator. That is the metal. Like if you see this is the copper wire, then it will be covered through plastics or rubber, because these are insulator and copper is conductor. So this was the description of conductor and insulator. Now we discuss about electric potential. What is electric potential? In electric potential, we see that the work done required to move unit positive charge from infinity to that point. Like this is our charge and another charge, that is unit charge. We can do some work moving this unit positive charge from infinity to this point, and we can do some work in between this, from moving unit positive charge from infinity to this point, called electric potential. We can easily say work is done in moving unit positive charge from infinity or infinite to another point or one point called electric potential. Now, what is potential difference? Now, what is potential difference? It is also said, work done required moving unit positive charge from one point to another point called potential difference. That is, work done required to positive charge, unit positive charge from one point to another called potential difference. Potential difference. And from these definitions, we found a mathematical formula for potential difference. Potential difference is equal to work done per unit charge. Potential difference is represented by V, work done is represented by W, and it is charge. And unit of charge is coulomb. Unit of potential difference is volt, and unit of work done is joule. Now we are discuss about our next topic, that is resistance. Yes, you know this. Let's discuss about resistance first, then again I will discuss electric current. So, what is resistance? You can easily define resistance as the obstacle present in path of electric current or electricity. The obstacle or hindrance present in path of electric current called resistance. It is denoted by capital R and its unit is ohm, represented and this symbol. Now, factors on which resistance depends. On which factors resistance depends? The first one is length of conductor or wire. Second one is area. Third one is nature of material. And fourth one is temperature. Now we are seeing here how it's depend on length of conductor of wire. Resistance is directly proportional to length of conductor and it's also inversely proportional to area. And nature of material, like it is less resistive or highly resistance. Or highly resistant material. And temperature, as temperature increases, resistance increases. As temperature decreases, resistance decreases. These are the factors on which resistance depends. Now, before starting Ohm's law, let's discuss something about electric current in details. And in the starting, I will discuss only its definition. And so now, discuss some important point about electric current. Then we start Ohm's law. So, as we discussed, what is electric current? The flow of charge or electron, called the basic definition. It's the basic definition of electric current, that is the flow of charge or electron, called electric current. Now, what is the unit of electric current? Unit of electric current is ampere, denoted by capital A. Now, by capital I, we denote electric current. Electric current. Okay. As we discussed about charge, that is, it is represented by Q and its unit is coulomb, that is capital C. From this concept, we have our formula, mathematical formula, I equal to Q upon T. So, by the help of this mathematical formula, we can define electric current is rate of flow of charge per unit time. Mathematically, we say charge per unit time. Its electric current, charge per unit time is electric current. Now we are discussing about Ohm's law. What Ohm says. Ohm's law. Ohm's law says the potential difference is directly proportional to electric current, that is V is directly proportional to I. And for remove this proportionality, we can use here resistance, that is V is equal to I into R. So, as potential differences increases, as V increases, I also increases, and R might be constants for any term. As V increases, I increases. Ohm's law says. Ohm's law gives relation between potential difference and current. It gives relation between potential difference and current. In this Ohm's law, we can only see about how potential difference is related to current. On this formula, you can easily solve some numericals also. And as we say, E equal to IR, we can also say I equal to V by R, and that from here we see I is directly proportional to V, I is directly proportional to 1 by R. So as I increases, V increases, but I increases, then R decreases. This is the relation that Ohm's law give to us. Now we can discuss about resistance and its effects. Before discussing resistance, we have to also see a term resistivity, how it comes. So as we know, resistance is dependent upon length of conductor, also 1 upon area. Now, how can we remove this proportionality? For removing this proportionality, we can add a constant, that is rho, where it is resistivity or a specific resistance. Or a specific resistance. Okay, it is read as rho, R-H-O, read as R-H-O, and its unit is